we have studied the Anjali, velocity by two methods. Two methods are there to study the velocity in mechanisms. One method we already did, that was eye center method. Okay, and in
Yes, sir.
eye center method, we discussed this thing that if we know that this one is my link, so this one is my link. So if this is my point A and this is my point number B, and if I know the eye center location, suppose this is my eye center, so simply join point A with eye center, that AI length divided by the velocity of the point A will give the angular velocity of the link. This thing we discussed in the previous
Okay.
classes. So examiner
Yes,
used to give that omega
yes, sir.
AB indirectly. He used to give the RPM, so 2 pi n by 60. This is how the angular velocity can be calculated. And in the similar way, AI distance comes out to be after the drawing the eye center diagram, and AI length is divided by VA. So this is how the velocity of the point A can be calculated. If we want to calculate the velocity of the B, then similarly join B with I, and that is also equal. That is also equal VB by AI. Okay, so the
Okay.
our main motto is to find out the eye center. If we know the eye center, then I can find the linear velocity also. And how the linear velocity component is there? Perpendicular to the link. And the velocity of the point A is also VA perpendicular to the link. As many as points are there between A and B, infinite number of points are there. If I want to find out the velocity, suppose this is a point number C, then do simple thing, join C with our eye center. This is the direction VC, and this is the method VC by CI. Okay, that was eye center method. But this diagram, the diagram which we are going to study right now, these are also velocity in mechanisms method, but this method is known as relative velocity method. Okay, in your previous exam, I saw the previous year paper when we do the class in the previous month. Then they asked the
Yes, sir.
velocity diagram also, and eye center, both question they asked in final exam. So motion of the link, this thing I already told you, na? This is VBA,
Yes, sir.
and omega is the angular velocity. So as many as points are there, suppose C point is there, then it will become VCA. The thing is that Anjali, that is written as VBA, velocity of B with respect to point A.
Respect.
Suppose point
Yes.
A has been kept as fixed, then we can call that VBA is VB. That is known as absolute velocity, because A point is fixed, na? So either
Yes, sir.
avoid the A or to write A, both will represent the same thing. Okay, so relative
Okay.
velocity method is a little different, but not that much difficult. That's also easy. So directly we will came onto the problem, and you will get to know how the velocity diagrams are being drawn and how the calculations are being made. There is no any
Okay.
method of it, because in eye center there was a method, na? Three eye center will lie on a straight line and all these things, but here things are different. Okay, let me show you one numerical, then you will have a brief idea, sir. This is how the numerical is being asked. Suppose this kind of a problem, generally they used to ask the 4-bar mechanism problem. This is the simplest problem. They are saying that a 4-bar chain is there, A, B, C, D, and AD link is kept as fixed. In the diagram itself, they are giving the diagram, and they are saying that AD is fixed. Okay, and length
Okay.
is 150 mm long. This 150 mm long, and AD is being kept as fixed. The crank AB is 40 mm long. Smallest link is the crank, naturally, and they are giving the 120 RPM clockwise direction. Why? Because the crank can rotate at 360 degree. Na? Complete rotation can be possible. Smallest link is adjacent to the fixed link. Okay, so these things we discussed in the chapter number 1, and the link CD is 80 mm and CD, sorry, and oscillates about D. Okay, about point D, the link CD what oscillate. This link rotate actually. This link rotate at 120 RPM, but this link cannot rotate at complete 360 degree. This link can only oscillate. About which point? About D, because point D is fixed now. So CD link has only one option, either to move left or right. That motion is known as oscillatory motion. Okay, that is complete rotation. That is oscillatory. That can move in this way, left, right, left, right. Okay, so to and fro motion.
Okay.
So BC and AD are equal length. So this BC and AD are of equal length, 150, 150. So our main point is so angular velocity of the link CD we need to find out. Okay, this link CD angular velocity we need to find omega CD. Generally in university exam they used to ask only the magnitude, but in the GATE they used to ask the direction also. Okay, angular velocity they are asking only angular velocity. I will solve the question with both method, eye center method and relative velocity. Whatever you find suitable, do apply that method, because in the exam either they will mention or they not mention. Then you can do any method. If they are saying that locate the eye center also, then go for eye center method. Simply they are asking the angular velocity, then this method is also applicable.
Okay.
Okay, then angle BAD is 60 degrees. So our first purpose is to draw the configuration diagram, or you can say space diagram. Space diagram, that also known as configuration diagram. So how to draw the diagram? Because see 150, 80, 150 mm, 40 mm, they are pretty large length, na, actually. 150 mm is about 15
Yes.
centimeter. So if your answer sheet is there, then you need to rotate the answer sheet into landscape mode, and 150 mm. So configuration diagram will occupy the whole page. And where will you draw the velocity diagram?
Yes.
Okay. So 1 second, Anjali, 1 second.
Yes, sir.
So so how to draw this configuration diagram? We need to descale it, Anjali, because 150 is very large length, na? So make the diagram in half scale. You better know how to draw in half scale. You have studied the engineering graphics, na?
Yes.
So I am giving you a basic overview. Suppose I am saying that 1 centimeter is carrying the 20 mm length. Okay, so 150 will carry 7.5 centimeter, na? 150 mm length. Okay, so you need to draw the 7.5 centimeter line. This is known as link A, this is known as link D. So 50 has been reduced to 7.5 centimeters. So this one was what? 15 centimeter, na? Or you can say instead of 150 mm.
Yes.
So AD, so put your protector in this way. I think you don't know how to draw the configuration diagram. That's why I'm saying put your protector over here and draw a 60-degree angle at point number A. Okay, and what would be the length? 80 mm, na? 80 mm. So 80 will become what? 4 centimeter. Okay, because 1 centimeter is carrying 20 mm. So this is 4 centimeter. So this location will become our point number B. That angle is 60 degree. You need to put the protector in this way. There is a hole in the protector, na? Or there is a marking over here. That mark should coincide with point number A.
Yes.
Okay, because generally student used to ask, sir, where to put the protector, how to draw 60-degree diagram, because many of the student hasn't studied the geometry properly in 8th, 9th class, na? That's why I am telling you how to draw this. So two things are clear. Then this was what? 7.5 centimeter. That was what? 4 centimeter. Then open the compass again 7.5 centimeter, because CB link is also having 150 mm length, na? Put the compass needle on the needle on the point B and mark an arc of how much length? 7.5 centimeter. Similarly, how much this is length? 80, na? So sorry, this was 40 centimeter actually. That was 40 centimeter, so it will become 2 centimeter. Okay, that will become 2 centimeter. And so now open the 4 centimeter and cut it over here. So this is how the configuration diagram can be drawn. This will become again 7.5 centimeter, and that will become 4 centimeter. Clear? So this is how the configuration diagram can be drawn, and you don't have any need to write 7.5 centimeter, 4 centimeter. Write the given data. Don't write this data. This data is just for your convenience.
Okay,
So put this thing at least. Let take the scale 1 centimeter is equal to 20 mm for configuration diagram. For configuration or space diagram, you need to write in the, because you must have drawn the graph paper in the 8th 9th class, na? So how to write the one box
yes.
is equal to 20 units, and this is how you need to look at the uh, graph dimension, na? So this diagram is clear to you?
Yes, sir.
Okay, so now
Yes, sir.
this link, AB link is the crank, and that rotate at 150 RPM or whatever. So can't I calculate omega AB, Anjali? That yes, I can. Omega AB or omega BA 2 pi n by 60. So RPM has been given to us. RPM is 120, na? So omega AB comes out to be 2 pi 120 by 60. So that answer comes out to be how much, usually? 12.568. 12.568 angular velocity is there, na? So unit will be radian per second. Correct? And
Okay.
what about velocity BA? That was also BA, na? Let it correct. Omega BA. So what is the formula of VB, Anjali? R into omega BA, isn't it? What would be the radius,
Yes,
Anjali?
sir.
That AB length, na? AB is how much? 40
Yes, sir.
40 mm.
40.
40 mm will
Yes,
become
sir.
40 by 1000. So 0.004 or what? 0.004, 40 by 1000.
Yes,
No,
sir.
0.
Okay.
I think 0.4 will be
Zero,
there.
zero,
Not single zero would be there. 40,
4.
40 by 1000. Okay, 0.0. Sorry,
Yes.
0.04. Okay, put a 0.04 instead of radius and multiply by omega BA, that is 0.04 into 12.568. This is how the first linear velocity has been calculated. Correct? So a linear velocity is calculated, then we can go for the velocity diagram. That's very easy step. We haven't done anything. That is the given data. Okay, so VBA. Okay, VBA is the given value. So we will use this later on. We will use this later on. And Anjali, remember this thing, VBA can also be called as VB. VBA, because this one is a fixed link, no, Anjali? This is a fixed
Yes, sir.
link. This is a fixed link. And what would be the direction? Perpendicular to the AB link. So that angle would be what, Anjali? 90 degree. Okay, so that angle would be 90 degree, and that will represent VB. You can also write VBA. So first velocity component of point B has been denoted. A and D are fixed points. They don't have velocity. Velocity will be only B point, C point. That's it.
Okay.
Okay. So after drawing the configuration diagram, we need to see how to draw the velocity diagram. I will first I will show you here. Then later on I will tell you in the white paper also. Okay. So VBA comes out to be actually what? 0.503 meter per second. You can see clearly. VBA can also be written as VB. Okay, and that angle is our 90 degree. So Anjali, see how to draw the velocity diagram. This point D is fixed. This point A is
Yes,
also
sir.
fixed. If
Yes,
two
sir.
points are fixed, name them a single point where whatever the location suits you. Suppose this location suits you, mark a point, single point, and make the small alphabet A, D. Okay, because A comes out to be earlier in the alphabet also, na, and B, C, and D. Don't write D, A, because A is coming initially, na. So that's why we are assuming that A point comes out to be first. A and D, very easy to mark because they are fixed link.
Yes, sir.
Now comes the velocity diagram process. You need to draw this VB. How to draw that thing, Anjali? Put your protector over here. Suppose this line is going in this direction. Put your protector in the rotating manner, and the protector center is lying over here. That 90 degree line is coming, Anjali. That is at 90 degree,
Okay.
and that would be perpendicular to the link number A. Correct? So I'm telling you how to draw the 90-degree diagram. I am sure you know if this is the line and this is the center point, and if I'm saying that draw a perpendicular to this AB line, I think you better know what would be the direction. That would be direction, a 90-degree. So put your protractor at the center of B. Can you draw that, Anjali, or not?
Yes, sir.
Okay, because I'm assuming that that's a very easy geometry. You must have studied the engineering graphics. In
Yes,
the
sir.
graphics, we have done this thing. So parallel to this VB component, we need to draw another line. That line is also parallel. So now here comes the challenge: how we can draw both these line as parallel line. When we were student, our professor was unable to tell. I'm sure he doesn't know how to draw the parallel diagram. He used to teach on the board that draw parallel, parallel, parallel. But we are unable to identify how to draw the parallel line without the help of drafter. In the engineering graphics, we used to draw the parallel line with the help of drafter, Anjali. So, but
Yes, sir.
what we used to do, we used to put the scale over here because scale is in this way, na? And we used to
Yes,
draw
sir.
a light line. Again, we used to put
Okay.
our scale in this position and again in this position. So all these
Okay.
lines are parallel, na? So we used to
Yes,
follow
sir.
that method, but that method is very lengthy. So go for our what? Set square method. There are set square, na? Set
Yes,
square
sir.
comes out to be in this way. Do you know how to use the set square or not, Anjali?
Yes, sir.
There is a set, na? There is a set of these squares. So join them and suppose this is my line, this line will be again parallel. I think you better know how to use the set square.
Yes, sir.
My aim is to tell you what would be the length of this line, AB line, because I know na VB velocity, that would be 0.503. 0.5, suppose I am assuming that 1 centimeter is equal to 1 meter per second. The 0.5 would be what? Half centimeter line, na Anjali? Half centimeter is very small length. So again,
Yes, sir.
you need to write the
Scale.
scaling for that velocity diagram also. So let us assume that 3 centimeter or suppose 4 centimeter. Let us assume that 4 centimeter is representing. I am taking the round figure, Anjali. I am not taking 0.503, 0.5 meter per second. Correct? So 0.5
Yes, sir.
meter per second. So what would be the length of this line, Anjali? 4 centimeter, na? 4 centimeter,
Yes, sir.
and that line would be again parallel in this way.
Okay.
Some students used to do this question in a different way. Okay, so because they know that this is 60 degree, this is 90 degree, so this line would be what? 30 degree. Okay, so
Okay.
if this is our horizontal line, then we know that this is my 90 and 90, and what would be this angle, Anjali?
30.
Again 30, na? So
30
30.
degree.
So
Yes,
they
sir.
used to draw the 120 degree angle. They used to draw the
Okay.
horizontal line, and they used to draw 120 degree angle instead of this. So this angle
Okay.
is will again become. So there are different methods, but I know this method is time consuming. If this question comes into your exam this time, then do that question at the end of your paper. That question must be your last question. Okay.
Okay, sir.
So because that consume a lot of time. If you do the practice, then it will hardly take 15 or 20 minutes because your exam is of 1 hour. That's why I'm saying. So I
Okay,
think
sir.
that point is located, AD point is located. Here comes the next point, that what would be the C position. C can move with respect to fixed point D also, and with a moving point B also. 2 points are rotating the point number C, Anjali. B and D both. When we are taking the C motion with respect to D because it is oscillating, then what would be the velocity CD? That is also called as VC, na? VC is equal to
Yes, sir.
VCD because that is absolute velocity and reference point D is fixed. So what would be the velocity component direction, Anjali? This component. At what angle? 90 degree of it. So that is known as VCD. Let us do in this way. VCD is equal to VC. Clear? So
Okay.
parallel to this line, VCD line, draw a line that is passing through the point number D because D is the reference point. Na? So parallel line should pass through D. Because some student used to ask, sir, can't we move this line in the backward direction? No, you cannot move because that is moving in clockwise direction. Na? So that
Yes,
is
sir.
very understood that C point will also move in the clockwise direction, isn't
Okay.
it? So
Yes, sir.
clockwise direction, correct? So C point, this line will go in this downward direction in this way. Now we
Okay.
up to now we don't know where the C point is located. C point will be located after the understanding of the motion of C with respect to B. So the C position would be perpendicular to the link number BC. That would be again 90-degree angle, na? And you need to write VCB, velocity of C with respect to point B. Okay, and that would be perpendicular to the link number CB. Correct? So, and see this thing that we are drawing that in upward direction. Na? If we will draw that in downward direction and that in backward direction, so they will not meet. Okay, Anjali. So that direction must be upward so that the intersection point will give the small C point. Okay, so this is how the C point can be located. That can be written as velocity CD, that can be written as velocity CB, that can be written as velocity B, or you can also write as VBA. Okay, Anjali.
Okay.
I hope it
Yes,
is
sir.
clear how to draw the velocity diagram. Now,
Yes, sir.
what the examiner was asking, examiner was saying that calculate the angular velocity of the link CD link. So measure this length, Anjali. Suppose, and it is looking like that velocity CD and velocity B are almost nearer to each other. Suppose this is 0.5, and suppose this one is coming out to be 0.35. Let us assume that is coming out to be 0.35 cm, because this is 4 centimeter. Na? We have assumed that is 4 centimeter. Suppose this is coming out to be 3.5 centimeter. Okay. And this is how, and we will do the descaling later on. Okay. We will do the rescaling later on. Suppose this is coming out to be 3.5 centimeter. So if 4 centimeter is representing 0.5 meters per second, then what the 1 centimeter will represent? 0.35 by 4. And what the 3.5 centimeter will represent? Multiply by
Okay.
3.5. So this is how we need to do the descaling. The descaling part is also time consuming, but the method is not that much difficult. How to understand this problem.
Yes, sir.
So,
Okay.
so VCD, we will measure this thing. Suppose this is coming out to be, let me do the little correction, 0.4 meter per second. Okay, 4 meter per second, that is linear velocity CD, and he is asking the angular velocity. What would be the formula, Anjali? Radius CD multiplied by omega CD. Okay, we know the radius
Okay.
CD, na, Anjali? 80 by 1000, 0.08. Put 0.08 multiply by omega CD, and that is equal to 0.4. Okay, 0.4 by 0.08. This is how the omega CD can be calculated. Okay.
Okay.
So
Yes, sir.
if he is asking that calculate the velocity of the link CB, then do the same exercise. Measure this length and this length magnitude in the meter per second, not in centimeter. Not according to scale, according to the meter per second, that is equal to 0.15 multiplied by omega CB. This is how the angular velocity of the link CB can be calculated. Correct? So let us see
Yes, sir.
what the answer is coming out to be. Velocity CD. Okay. Okay. We were somewhere close, na, Anjali? We were saying that that was 0.35 initially. Later on, we have taken that 0.4. So we were
Oh,
somewhere nearer to our answer. So
yes, sir.
0.385
Okay.
and divided by 0.08, our radius is coming out to be 4.8 radian per second. So examiner is asked, if the examiner, suppose this is a gate question and examiner is saying that tell me the direction also. So in this Khurmi book, the denotation is a little different. Let me tell you how to find out the location. How to find the, sorry, direction. See, C is where, Anjali? Top. D is where? bottom, na? And in the diagram also. In the diagram, what is happening actually? C is in the bottom, D is at the top. Reverse is happening, na? Anjali?
Okay.
Reverse is happening, na?
Yes,
If
sir.
reverse is happening, then it is having anti-clockwise direction. If the diagram C D is over here, suppose D is over here and C is over here, then C is on the top, D is on the bottom, then it is pretty clear that C this is matching with this our space diagram, then the direction would be clockwise. In the R.S. Kurmi book, in the SS Ratan, the method is correct, but he's saying that clockwise above D. Okay, that's incorrect. So we need to identify whether it's matching with our space diagram or reverse of it. Okay,
Okay.
so this is how the velocity diagram answer comes out to be. Now I'm telling you how to calculate with the eye center method. Eye center method is little easier than the this one. Suppose only we have drawn the space diagram also. Okay, this was the space
Okay.
diagram, na? And that was 150 and 40, 80 and 150. Okay, suppose this one is my point A, B, C and D. And with the help of eye center, that question will consume very less time. I will tell you how.
Okay,
So
sir.
suppose this is my link fixed link, na, actually. Suppose this is link number 1, this is link number 2, this is link number 3, this is link number 4. Correct, actually. So what will be the eye center? 4 into 4 minus 1 by 2. How many eye center would be there? 6 eye center will be there, na, actually. Okay. What would be their name? 1 2, 1 3, 1 4, 2 3, 2 4 and 3 4. These are the name of them.
Okay.
Okay. If pin joint is there, so this is the eye center pin joint of 1 and 2, na? So erase this for a while. That eye center name will become I12. That eye center name will become I23, and that eye center name will become I34, and that eye center will become I14. Correct,
1, 4.
actually. So 1
Yes,
2
sir.
we know, 1 4 we know, and 2 3 we know the location, and one more is there, I34.
3.
Only 2 eye center we
Yes, sir.
don't know, and how to identify them. This diagram will help us, isn't it, actually? 1
Yes, sir.
2 3 4. Join the diagonal with a dotted line. What are the eye center that will be collinear, actually? I hope you don't have not forgotten anything, because we did a few days back, around
Yes,
20
sir.
25 days back, in the last lecture. This was the last lecture. Eye center number
Yes, sir.
1 2 2 3 and 1 3 will be collinear. Correct? This
Yes, sir.
triangle, this triangle. And similarly, I 1 4
1, 4,
3 4
3, 4.
and 1 3 will be collinear by bottom
Yes,
triangle.
sir.
Correct?
Yes, sir.
So I know that I 1 4 is this one. This is I 3 4. So we know that the remaining eye center will be I13 will be on the same line. On this line,
Yes, sir.
our I13 is going to lie. And we know that I23 and I12. These are the also eye center. Na? So I13 will also
Yes,
lie on the
sir.
same. So that is possible only when we'll extend this line and they will intersect over here. And that would be
Yes,
the
sir.
I13 location. We know that thing, correct? And the
Yes, sir.
same for the this diagram. What are the eye center name? 1 2, 2 4 and 1 4. That are collinear. Similarly,
Yes, sir.
I24,
2, 3,
2 3 and 3 4.
3, 4.
Correct? Correct.
Yes,
So
sir.
1 2 and 1 4 we know. So 2 4 is coming on this straight line. It can be over here, it can be over. On this straight line, the 2 4 is coming out to be. Similarly, 3 4 and 2 3 also know. We know. So this straight line will give you the I24. Let us extend up to
Yes, sir.
here. That intersection point will give you I24. That is pretty easy, na? Simply extend this line. Extend this line, and
Yes,
you
sir.
will get to know what is the eye center location. So Now I am telling you how to calculate the angular velocity by applying the angular velocity theorem only. So let me recall to you what was the angular velocity theorem. Then you will say, sir, this method is very easy to me. Okay, so
Okay.
and measure the distances also. So he's saying that this is rotating with 150 RPM clockwise. Okay, omega 2 he's giving, omega 4 he is asking. Correct? Omega 2 he is giving, omega 4 he is asking. So how to apply the angular velocity theorem, Anjali? 2 4 na? 2 4 combination is there. So let us write omega 2 is equal to omega 4. We adopt this method na. So put the bracket on the both side. Put the bracket on the both side. Write I. Correct, Anjali? So let us write 1. Let us write 1. What is the next 2? This one is the 2. Here 4. Correct? Now you
Yes, sir.
repeat this one. I 2 4. I 2 4. We know the omega 2 na, Anjali. I 1 2 2 4. I 1 2 2 4 would be this length na, Anjali. This length will be I 1 2 2 4. That green hatching. I 1 2 2 4. Measure with the scale. Measure with the scale. That distance simply you need to put, but in meter. Multiply by omega 2. And similarly, omega 4. I 1 4 and I 2 4. I 1 4 and 2 4 means that complete length, Anjali. That complete length. Measure this length also and put in the meter. It's easy, na? Now it's easy. So omega 4 will come out to be something will here, na? Something multiply by omega 2 divided by this thing. That one will be also in meter. That is also in meter. This is how omega 4 can be calculated.